Hello everyone, this is the video for lesson 2.2a, Characteristics of Quadratic Functions. We have two learning targets for the day. First one is I can use the properties of parabolas to graph quadratic functions. And the second one is I can identify the characteristics of quadratic functions and their graphs. We will be using two different forms in this lesson. The first one on page 1 is using vertex form. And it is easier for you to identify the vertex first and then identify the axis of symmetry. On the back of your notes, we will talk about standard form, and you need a different approach. So for standard form, you will be using axis of symmetry, and then you will identify the rest of the vertex. So you need to pay close attention to how the function is written and then your approach to graph afterwards. Before we start the examples, I do need you to look very carefully at this generic parabola. This is in the shape of a parabola, which is a quadratic function. And I want you to notice that the axis of symmetry is always x equals a number. And that number happens to be the first part of your vertex, which is your x-coordinate. So if you find your vertex, you know your axis of symmetry. It's going to be the same as your x-coordinate. If you find the axis of symmetry, that's going to automatically give you the first coordinate of your vertex. They are paired in that very special way. Let's take a look at vertex form. Notice how vertex form, it has A in the front. We have H with the X. And you have K on the outside of your function at the end of it. Now, you should be familiar with A, H, and K because those are transformations. A is a complicated transformation in the way that it can reflect if it's negative, or it can stretch if it's greater than 1, or it will shrink if it's between 0 and 1. H can either move the graph left or right, depending on what it is, and then K can either move your graph up or down. So let's look at this one specifically. We have a -2 for A. We have +3 for H. And we have -4 for K. So what we're going to do is we're going to talk about the transformations and what each does. So the negative part is going to reflect. It's going to reflect specifically across your x-axis. So it is going to look like this. This is very important you understand that. The 2, on the other hand, is going to have a vertical stretch, which is going to make your graph look a little skinnier. The reason why it does that is because you are multiplying each y-coordinate by 2. It's pulling it away from the x-axis, which makes it appear skinnier. The +3, on the other hand, is going to do the opposite of what you expect it to do. It's actually going to translate left 3. Now, if you translate something left 3, what it's going to do is it's going to move that vertex. Your parent function starts at 0, 0. So your vertex is going to move left 3. So we got to pay attention to that. And the other one, the 4 over here, that is going to translate it up 4, which is also going to change your original vertex in your parent function. So if your parent function starts at 0, 0, if you want to move that left 3 and up 4, your new vertex is going to be -3, +4. So if you have a function written in vertex form, it is very easy to write down your vertex considering if you know your transformations. Since you know the vertex, your axis of symmetry is always going to match the x-coordinate of your vertex. So if x is equal to -3, your axis of symmetry will be x equals -3. So what we're going to do is we are going to graph our axis of symmetry. This is your x-axis. Here is your origin. 1, 2, 3. So I'm going to draw a dashed line. This is your invisible line of symmetry at -3 on your x-axis. Your vertex is at -3, 4. Let me change colors. So -3 up, 1, 2, 3, 4. Now I know that my graph is going to face down because it has been reflected. So the next step for me is to find another point on this graph. So if you look below right here, it says use x is equal to -2 to find another point on the graph. So this is pretty easy. I can just go ahead and plug in -2 into my function. So instead of putting x plus 3, I'm going to put -2 plus 3. And then when I type that in my calculator, so this is what I'm typing in, I wound up with +2. So if I'm plugging it in, if I'm plugging in x as -2, my result is a +2. That gives me another point on my graph. Now, why did I choose this particular point? Notice how close it is to the axis of symmetry. If you pick a point like 0, sometimes you don't realize it's going to be very, very far away. It's so far away that you can't even graph it on your paper. So pick something close to x equals -3. So you could use -2. Instead of using -2, you could easily use -4. Now, since it's symmetric, -4 is going to give you that same value. So I have enough information to establish the curve and then the shape of the graph. If you want it to be a little bit more perfect, you can choose another x value. You could use -1 or you could use -5. Our second example is also in vertex form. So I'm going to take a look at the values for A, H, and K. So if you look at 0.5, it's not negative, which means that I have no reflection. If I'm not reflecting, then my graph will look like this. It's going to open up. I do know that I have a vertical stretch. No, a vertical shrink. My apologies. And it would be a factor of 0.5. And what that will do is it'll make your graph look a little wider because it is changing the distance from your y coordinates to x. It's actually making it shorter because multiplying by 0.5 will half the distance. The +4 is opposite what you expect it to be. So that means we are translating it left 4 places, which will change your vertex. So if you are going left 4, remember your parent vertex starts at 0, 0. Going left 4 will in turn make that vertex -4, which means H is -4. And then your -2 over here, that is going to translate down 2 places, which also changes your y value to -2. Since I know my vertex is -4, -2, I automatically know the axis of symmetry is equal to -4. And I can go ahead and graph my axis of symmetry. Here's my x-axis. I'm going to find -4. This is my invisible axis of symmetry. And my vertex is located at -4, -2. Now I know it's going to open up in some way, but I need another point on this graph. So I'm going to pick something close. Let's say we can use f of -3 because it's close to my axis of symmetry. And when I plug that into my function, I wind up with -1.5. So another point on my graph is -3, -1.5. Now there's a problem with this because it's so close to the vertex. The one on the other side that's symmetric is also very close. It doesn't give us a lot of information. So since it doesn't give me a lot of information, what I'm going to do is I'm going to find the y-intercept. I know that since it's a little bit wider this time, I can use a point further away from my axis of symmetry. And just this time, I'm going to choose the y-intercept. So that means x is 0. So when I plug in 0, I wind up with positive 6. So we would plug this into our calculator and it gives us 6, which means that another point on this graph is 0, 6. So I will find it. So it's up here. See how wide the graph is? So this is 4 away. So I'm going to go 1, 2, 3, 4 on the other side. And now I have enough information to establish the curve. Okay, so now we're going to change our form. We're going to use standard form. It's very important that you be able to recognize what form the function is written in. Standard form is very different. Standard form has no parentheses, and you have 3 separate terms. The only one you absolutely have to have is your quadratic term, which is ax squared. Sometimes you have a linear term, which is bx. And then you'll have a constant at the end. You might think you can see your transformations. The only ones that you could see are your reflection over your x-axis, or you can see if it's been vertically stretched or shrunk. You cannot tell if it's been shifted left, right, up, or down, unfortunately. So we need to approach this in a different way. So you can kind of tell right here, if A is positive, there's no reflection. And over here, if A is negative, there is a reflection. But we have something that's new that's very important. We're not able to tell what our vertex is according to our transformation. So what we're going to do is we're going to use this formula. And you have to be very good at this formula. This formula is not on your formula sheet, so you do have to memorize the formula to find the axis of symmetry if it is in standard form. This is x is equal to negative b over 2a. So you also need to know how to identify a, b, and c if your equation is in standard form. Okay, so first example in standard form, you can very clearly see you have 3 different parts. This is your ax squared, your bx, and your c. You cannot tell if it is translated up, down, left, or right. So what we have to do is identify these 3 values. A is 3, b is negative 6, and c is 1. If it is not in standard form, you need to rewrite it to where it is in standard form. It has to be either equal to 0, y, or f of x. All right, so we're going to very carefully use this formula to find our axis of symmetry, because if we make any mistakes here, it's going to throw our whole graph off and we're going to do a lot of work and it's going to be wrong. So make sure that you put your negative out in the front of your fraction. Go ahead and substitute b in the top, and then 2 times a in your denominator. And in your calculator, what you can do is you can type in negative and then fraction button, negative 6 over 2 times 3. So as long as you do that correctly, you're going to wind up with x is equal to 1. I cannot emphasize the importance of you finding your axis of symmetry correctly. So what I'm going to do is immediately write over here that my vertex has to match this axis of symmetry. If x is equal to 1, then x in your vertex is also equal to 1. So all you have to do now is you just plug it in to your function to find whatever 1 is, okay? So I'm going to write the function down, which is 3x squared minus 6x plus 1, and then I'm going to plug in the 1 underneath it. Okay, now you're not going to be able to use Desmos to graph it, but you're welcome to use your calculator to calculate using the formulas or plugging in numbers into your function. So when you plug that into your calculator, you wind up with -2. So that tells you your y value for your vertex. I'm going to go over here and find 1 on my x-axis. And the dashed line is your axis of symmetry, and your vertex is at 1, -2. Now I can tell that this does not reflect because this is positive. And this is actually easier than vertex form on this part. As long as your axis of symmetry is not 0, you can use this trick. So to find a second point on your graph, you can just use the y-intercept. And your y-intercept is so easy to find if it's in standard form. It's just 0, c. And in this case, c is 1. So if you want to look back up here at your notes, see how it's 1? There you go. So just find on your y-axis, +1, draw the symmetric line on the other side, and then you have enough to establish your curve. There you go. So you can tell that there is a different approach to the graphing. It's not that it's very difficult. You do have to do a little bit more work if it's in standard form. Okay, let's do one more example in standard form. I do have all 3 parts. Remember, the only part that you absolutely have to have in standard form is the ax² part. If you don't see any of the other 2, that value would be 0 for either b or c. So in this case, a is 0.5, b is -4, and c is -2. We're going to very carefully plug this into our axis of symmetry. B is -4, and then 2 times A would be 2 times 0.5. Carefully type this in your calculator and you wind up with 4. So our axis of symmetry is where x is equal to 4, which is right here. If I know my axis of symmetry is x equals 4, then my vertex automatically starts with 4, and I can go ahead and plug in 4 into my function. I'm going to write my function down first, then plug it in. Okay, if we type this into our calculator, we wind up with -10. Which tells us our vertex is for -10. So it's all the way down here at the bottom of our graph. So I do know that has not been reflected, so it's going to face up. And we're going to do the other very, very easy quick part since it's in standard form. An easy point for us to find is 0c. And in this example, c is -2. So I'm going to find 0, -2 here. And this is 4 away from our axis, so I'm going to do 4 on the right, and I have enough to establish a curve of the parabola. And that's it. So you do have some practice questions. You're going to start out with vertex form, and then I think you have one that is in standard form. So please, please, please practice this, and just let me know if you've got any questions, and you'll have a great day.